Hi Grade 8! I'm Teacher Joshua, your mathematics learning guide here at DepEd TV. Do you still remember linear equations and its solutions? How about on how to represent the line in a rectangular coordinate system? Join me in new chapters of learning that would help us be critical and logical thinkers. We will use the skills we acquired to show the solution of a linear equation in a graph. Make sure that you have your self-learning module, paper, pen, and the ruler with you, and let's get started. We have been learning linear equations through the previous lessons, and we use the rectangular coordinate system to graph its solutions. Recall that a rectangular coordinate system is formed by a horizontal number line, the x-axis, and the vertical line, the y-axis, that intersects perpendicularly. The intersection is called the origin and its coordinates is 0, 0. We discovered that graphing the solutions to a linear equation gives us a pattern. Do you still remember what is formed when we graph the solution? Given a linear equation, plotting its solution, which are infinitely many coordinates of points that extends on both sides, forms a line. Keep in mind that a linear equation has infinitely many solutions and they form a line when graphed. So, do we have to plot all of the points to get the graph of a linear equation? Remember, according to a postulate, through any 2 points, there is exactly one line. We only need at least 2 points to be able to draw the line. Let's take some examples. Graph the line that passes through the points 2, 3, and 4, negative 1. The position, direction, and distance of all points in the plane relative to the origin are given by its coordinates, the ordered pair xy. The x-coordinate or abscissa of a point is its horizontal distance from the origin, while the y-coordinate or ordinate of the point is its vertical distance from the origin. To graph this, we plot the point. Let's have 2, 3 first. The x value is a positive 2. This means that from the origin, the point is located 2 units to the right. Next, we are given a y value of positive 3. This informs us that the point can be located 3 units upward. Starting from the origin, we locate 2 units to the right, then 3 units upward. We now located the point 2, 3. The other ordered pair that we have is 4, negative 1. The x value is positive 4, and this means that from the origin, the point is located 4 units to the right. Then, the y value is negative 1. This informs us that the point is located 1 unit downward. Again, starting from the origin, we locate the point 4 units to the right, then 1 unit downward. We now located the point 4, negative 1. Finally, since we now have 2 points, we simply connect this to determine the line. Note that all the points found on this line are solutions to the same linear equation. And both ends of the line is an arrowhead to indicate that the solution has infinitely many points. Let's now graph the line that passes through 5, 1 and 0, 6. And we'll do it one by one. Plot first the point 5, 1. The x-coordinate is 5, so 5 units to the right from the origin. Then, 1 unit upward since the y-coordinate is positive 1. This is now the point 5, 1. Next is 0, 6. Since the x-coordinate is 0, there will be no horizontal distance from the origin. We proceed to 6 units upward because the y-coordinate is positive 6. we now have the second point, 0, 6. Last is to connect the 2 points. Therefore, this is the line that passes through 5, 1 and 0, 6. Now, what if we are looking for the line that passes through the points negative 7, 0 and 0, negative 4? First, we locate the first point, negative 7, 0. Observe that the y-coordinate is 0. Thus, we have here an x-intercept. Negative 7, 0 is on the negative 7 on the x-axis. Next is 0, negative 4. This time, the x-coordinate is 0. Therefore, we have a y-intercept. We can locate this on negative 4 in the y-axis. We determine the line by connecting these 2 points that we identified. That was easy, right? We simply plot the given 2 points, then connect them to draw the line. Note that the x-intercept is the abscissa of the point where the graph of the line crosses the x-axis. This implies that the point is on the x-axis, then the ordinate is 0, or x0. Similarly, since the y-intercept is the ordinate of the point where the graph or the line crosses the y-axis, this implies that the abscissa is 0, or the coordinates is 0y. So, for example, we are given an x-intercept negative 3 and the y-intercept 6. Simply locate negative 3, 0, which lies on the x-axis. Then, locate 0, 6, which lies on the y-axis. We are now able to graph the line by connecting these 2 points, negative 3, 0 and 0, 6. Now, what if we are only given 1 point and the slope? We may plot the given point, but we need another point to form the line. Can we use this to locate a second point? We have a slope, which will give us the information about the change in y and the change in x. We know that the slope m is equal to the so-called rise over run. From one given point, the other point can be identified with the help of the slope by observing the indicated change in the vertical distance or rise and the change in the horizontal distance or run. Let's take some examples. Graph the linear equation with 1 point at 4, 3 and the slope of 2. We first plot the given point, 4, 3. Since we have an x-coordinate of positive 4 and the y-coordinate of positive 3, we locate the point 4 units to the right of the origin, then 3 units upward. From this point, we take note of the change in x and the change in y from the given slope. Since the slope is 2, we may write this as 2 over 1 because the denominator of a whole number is 1. So, the slope 2 over 1 indicates that from the given point 4, 3, the other point is 2 units upward and 1 unit to the right. From this, we were able to identify the other point, 5, 5. We may now connect these 2 points to form the line. Observe that we may also interpret 2 as negative 2 over negative 1. This would give 2 units downward, then 1 unit to the left of the given point. The point 3, 1 is still on the same line. Next, let's graph the linear equation with a slope of negative 2/3 that passes through the point 0, 1. We only have 1 point, but we are given a slope that would help us to identify the other point. First is we plot the point 0, 1. Observe that the x-coordinate is 0, Therefore, we have the y-intercept here. So, we locate the point on the positive y-axis at 1. Since the slope is negative 2 over 3, we may identify the second point 2 units downward, then 3 units to the right from the given point 0, 1. And there, we now have a second point, 3, negative 1. Lastly, we connect these 2 points, and we now have the line. And that's how you graph given the slope and the point on the line. But what if we are given the linear equation itself? So consider this linear equation. Y equals 4/3 x minus 6. Observe that this equation is in slope-intercept form. Y equals mx plus b, where m is the slope and b is your y-intercept. In this equation, the slope is 4/3, while the y-intercept is negative 6. How do we graph this? Since we have a y-intercept, this means that we can identify one point, and that is 0, negative 6. While the slope 4/3 means that we have a rise of 4 units and a run of 3 units, which gives us an idea where to locate the second point. That is 4 units upward, then 3 units to the right of the y-intercept at 0, negative 6. So let's plot this. We have 0, negative 6 on the y-axis, which is the y-intercept. Then, from this point, we take 4 units upward, then 3 units to the right. This is now our second point, 3, negative 2. And connecting these points, we now have the graph of the linear equation y equals 4/3 x minus 6. Let's try this last example before we move to the evaluation part of our lesson. Graph the linear equation negative 10x plus 2y equals 2. This time, we have a linear equation in standard form, which we can rewrite in slope-intercept form. Do you still remember how to write a linear equation from standard to its slope-intercept form? Given negative 10x plus 2y equals 2, we want to isolate 2y on one side of the equation. We may use APE, or the addition property of equality, to add 10x on both sides. This gives us 2y equals 10x plus 2. We now use the multiplication property of equality, or MPE, by multiplying 1/2 on both sides of the equation to make the numerical coefficient of y equal to 1. Therefore, we have y equals 5x plus 1. Is this now in its slope-intercept form? We can now identify the slope, which is 5, and the y-intercept, which is 1. We can now proceed into graphing. Since we have a y-intercept, this means that we can identify one point, that is 0, 1. While the slope 5 gives us an idea where to locate the next point. 5 is equivalent to 5 over 1, which means 5 units as the rise and the run for 1 unit. Again, we will have 5 units upward, then 1 unit to the right of the y-intercept. Let's plot this point. We have 0, 1, which is on the y-axis. Then from this point, we take 5 units upward and 1 unit to the right. This is now our second point with the coordinates 1, 6. And last, connecting the points, we now have the graph of the linear equation negative 10x plus 2y equals 2. These are the ways to graph your linear equation, as long as we have at least 2 points, or we are given the slope to find the other point. If you want to be sure of your graph, you may also take another point to check. Were you able to understand our lesson for today? We were able to use our knowledge in the rectangular coordinate system in graphing the solutions of a linear equation. Let's take a recap on everything that we have encountered in this lesson. First, linear equations have an infinite number of solutions that can be represented by graphing the line. Number 2, at least 2 points can determine the graph of the line. 3, a linear equation written in the form ax plus by equals c is said to be in standard form and can be written in slope-intercept form y equals mx plus b, where m is the slope and b as your y-intercept. Next, the slope m is the change in y over the change in x, or the rise over run. The x-intercept is the abscissa of the point where the graph or the line crosses the x-axis. This implies that the point is on the x-axis and the ordinate is 0. Similarly, since the y-intercept is the ordinate of the point where the graph or the line crosses the y-axis, this implies that the point has an abscissa equal to 0, or the coordinates 0y. Now that we have finished the lesson, it is important to evaluate and see what you have learned. Make sure that you have your paper and pen with you. I will give you 5 seconds to answer each item. True or false? To graph a linear equation with y-intercept at 0, 4 and the slope -3/7, we locate the next point by moving 3 units downward, then 7 units to the right of the y-intercept. This is true. The slope is the change in y over the change in x, or the rise over run. Therefore, we have the horizontal change in distance, then we proceed to the vertical change in distance. Number 2, true or false? The graph shows the line with x-intercept at -6, 0 and the y-intercept at 0, -4. This is true. The intercepts were plotted correctly. The x-intercept on the x-axis and the y-intercept on the y-axis. Number 3, true or false? Given the x-intercept x equals 7 and the y-intercept y is equal to -3, the graph is shown as this. The answer is false. Observe that the intercepts were not plotted correctly. The x-intercept x equals 7 should be 7 units to the right of the origin, while the y-intercept at y equals -3 should be 3 units downward from the origin. Number 4, true or false? To graph the linear equation y equals -3x minus 2, we consider the slope -3, while the y-intercept is -2. This is true, since the equation is in slope-intercept form, y equals mx plus b. M is the slope, while b is the y-intercept. Last question, true or false? This shows a graph of the linear equation with the slope 2/5 that passes through the point -2, 3. This is false. From the point 2, -3, the other point will be located using the slope 2/5 should be 2 units upward, then 5 units to the right of the given point. But the graph showed a slope of 5/2 instead of 2/5. How was that exercise for your mind? Were you able to graph the lines? There are some mobile apps that can help you illustrate the linear equation on your rectangular coordinate system. Just use them wisely for checking, or as guide that will lead you to the correct answer. As an additional exercise, you may answer the activities and assessments on your self-learning module. You can also visit the DepEd TV official YouTube channel to watch and review our episodes and lessons. With that, have fun, enjoy, and appreciate your surroundings as we continue in being more critical, logical, and responsible thinkers. Next episode, we will find the equation of the line using different methods. Again, this is Teacher Joshua reminding you to keep safe, have a nice day, and see you next time for a math terrific learning. Because here at DepEd TV, we will never let your learning hindered by anything.